Hey there. I wanted to put this video together just to go over my method for making the nonogram. I know I've received a little bit of criticism for my method, being told that it's got too many steps, it's unwieldy, and that's absolutely true. I can't argue with any of that. If I was doing an art piece and I wanted to put in a 9-sided figure, I probably would not use this method. But I need to point out the things that are revealed by this method. There's some really neat relationships between the circles and the properties of the seed itself that come out in this method that I really want to just draw attention to, because I find it fascinating that it would work this way. So what I've done is I've pre-drawn these circles because I don't want to make you sit there and watch me draw seeds. You know how to do them. It's tedious to watch. So I've already pre-drawn them just to let you know what structures we're using for this method. And for our start, we're going to use a standard seed. Okay, and I'm realizing as I do this that my letters are backwards in the camera. I'll see if I can figure out a way to not have to draw on the paper so that you can see these properly. But what we've got is a standard seed drawn on a horizon. You've seen a million of them. But the thing to take away from this is you've got two radii that become apparent just straight out of the architecture of the seed. So we've got radius A, which is the radius of all of the circles of the seed. We've got the second radius B. And why do we need it? Well, it's kind of interesting because if you look at the seed itself, you've got 6 points on a 360-degree circle. So that gives you 360 divided by 6, which gives you 60 degrees. So you know that each one of these points are of intersection for all of these 7 circles is at 60 degrees. Now, if we think of the nonogram, you've got 9 points that reach the edge of the circle. And if you divide 360 by 9, that gives you 40 degrees. So each one of your points would be at 40 degrees of that circle. And if we do a little bit more thinking, the ratio or the relationship between 60 and 40, if you divide 60 by 40, you get 1.5. So 60 degrees is 1.5 times 40 degrees. Make sense? I hope so. But then we look at the seed again, and we see that a 1.5 is naturally in the design of the seed. If you take your radius of the original circles, okay, so here's our center circle, and you have your radius. And then you take this intersection. We know that this intersection is the midpoint of the radius of this circle. So by default, this point gives us line B, which is 1.5 times the radius of the original circle. That seems like a weird coincidence, right? Like, it's kind of curious to me. So that brings us to our second image. And all this is 2 seeds, okay, one drawn on this axis and one drawn on this axis. And for the purpose of the final diagram that I've drawn, all you really need to remember is that structure has a radius that's 1.5 times this structure. Okay, so just to say that differently, we have a seed of radius r, and then over top of that, we're going to drop this circle with a radius of 1.5 times r. All right, and they're going to be superimposed on top of each other. I hope that makes sense, because watching me draw it will take quite a few minutes, and I don't want to put you through that. Okay, but keep in mind, we've got our seed, and then on top of that, we've got our double seed, and the double seed is 1.5 times the radius of the original seed. So let's take a look at that. Bear with me, I'm going to flip my page here. That gives us this image, which of course I'm having trouble fitting into the camera. So you can see the circle for our radius r, and you can see the circle for our radius r times 1.5. Okay. And quite, I wouldn't call it miraculously, but it's pretty amazing. I'm smiling as I say it. The intersection of the larger circles on the smaller circles does indeed reveal a nonegram. And I'll just highlight those in some pencil in case I have to redo this video. I got something easy to erase. But what we've got is our point 1, point 2, point 3, 4, 5, 6, 7, 8, and 9. Okay, and for anybody that's really curious, of course, you know who I'm talking to, but if you're really curious, 3 of these points, I'm just going to draw a triangle to highlight them. 3 of these points are from the original smaller seed. Okay, they form the, the orientation I chose here, this would be the male half of the star. Okay, these 3 points here, so 1, 4, and 7 come from the original smaller circle. The remaining points, 2, 3, 5, 6, 8, and 9, come from a combination of the 2 larger seeds superimposed and rotated on each other. Okay, it's quite a mess of lines. It's hard to tell which is which. I could do another one with different colors so that they're more clearly visible, and I may. But for now, for the sake of this, you can see that a nonegram does emerge from 2 circles related to each other by 1.5 times their radiuses superimposed on each other. And that is amazing. It's absolutely amazing that would happen that way, in my humble opinion. What the deeper ramifications of that could be, I'm still giving that thought. But I find it fascinating. I really, really do. And I just love this method because it reveals that. Given that I would never use this in any kind of art project because it's a mess of lines. But it's absolutely remarkable to me that it does this. So I just wanted to share that. I would also point out, I need to do more research on this, but I do find it curious that the way this interlocks, or the way these images emerge, does kind of mirror what Tesla's image had. I'll draw it loosely here, but I mean you've got these 2 points coming down to here. I can't remember if it's this one or this one. Like I said, more research is needed. You got these 2 points coming down to here. Actually, I'll do it that way. And you get that kind of W pattern that falls underneath the triangle. I find that curious that it would work out that way, like hinting more that he was aware of something that was going on here. I don't think it's a coincidence that his pattern chooses this, but yeah. More research is needed on my part in order to understand how this is going on, but it's occurring naturally. Like you've got the 3 points on the smaller circle and then the 6 points on the larger circles. It's pointing at something. So more thought is needed, but I just wanted to point that out. All right. With that, I'll leave that with you. Let it cement in your mind. And yeah, we'll talk soon.